This is review number 2 for Unit 4A. Our circle vocabulary looks exactly like it did on the first review. So a chord is going to be endpoints on a circle line segment, so CD. You could have also said FH, that's a diameter. So let's go ahead and do number 6, FH. Tangent line. Tangent line touches the circle in one spot. That's IG. Notice it has arrows at the end of it. Radius, EJ, EF, or EH, any of those would work. And number 4, a secant line. Secant lines touch the circle twice. So I'm going to say A, B. Center is E. And point of tangent, C, is where it is tangent at. That would be point J. Similar problem here, except we got some different numbers. So arc FE. FE would be right here. It's our vertical angles. So that is 39. And arc CD. CD, I'm going to cut the circle in half right here. Cut the circle in half and say 180 minus the 39 and 93. 180 minus 39 and 93 is 48. So that means this is going to be 48 as well. This is 39. This is 93. Arc BF. BF. I'm going to cut the circle in half right here. And I'm going to say 180 minus the 39. 180 minus the 39 would be 141. Arc CF is half the circle. 180. Arc CFD. CFD is everything except for that 48. So I'm going to say 360 minus the 48. And that is 312, I think. Arc EBC. EBC is right here. EBC. We said this was 141 up there, didn't we? So I'm just going to say 39 plus 141 plus 39. So maybe 219. Arc CE. CE is right here. I'm going to add 48 and 93. That is 141, I think. Arc BDF. BDF. I think it's what right here. BDF. That would be 39 plus 48 plus 93 plus 39. I think it's going to be the 219 again. Same kind of deal right here as the first review. We got 2 intersecting tangent lines, and those segments between the circle and that point of intersection out there, point B, they will be equal. So I've got 4x minus 6 equals negative x plus 9. Add the x over, you get 5x. Add the 6 over, you get 15. X equals 3. All right, so we've got BE is 64 right here, and we got DF is 130. 130. Angle BDC. BDC is right here, just like that first review. It opens up to half the circle. So there's my center of my circle. That BDC opens up to half the circle. I'm saying 180 divided by 2, and that is 90. Angle EDB. EDB opens up to 64. I'm going to say 64 divided by 2 and get 32. Angle BFE opens up to the 64 as well. So I'm going to say 64 divided by 2 and get 32 right here. Angle DBF opens up to the 130. I'm going to say 130 divided by 2 is 65. Angle DGF, we're going to come back to that one, okay? Well, let's do it right now. DGF, that's right here. Let's put an X right there. That's one of those interior angles. So I'm going to say the angle x equals 1/2 big arc plus the small arc. That's 194. That's 97 degrees. Arc BDC, that's half the circle, 180. EC, EC, well, EC is right here. I'm noticing that this is half the circle, so I'm going to say 180 minus that 64. 180 minus 64 is 116, I believe. And angle BFE, it says angle and arc. That's dumb. Let's make it an arc. What do you say? Arc BFE. That goes from all there. 360 minus 64 is 96. Got an exterior angle. So we've got the angle equals 1/2 big arc minus small arc. The angle is x equals 1/2. Big arc is 160 minus a small arc 80. X equals 40 degrees. We got an interior angle here. So the angle equals 1/2 big arc plus small arc. The angle is 118 equals 1/2. The big arc is x plus the small arc is 66. That's 118. If you distribute, it's 1/2 x plus 33. And you subtract the 33 over, and you get 85. So I've got 85 equals 1/2 x. Divide by 1/2 on both sides. And x equals 170. How many common tangents? We went over this in the first review. So if they're separated, you could draw a tangent right there. You could draw a tangent right there. And you could draw a tangent right there. You could draw a tangent right there. That's not a good one. So 4. If there's a right angle in there, the 90 degrees right there tells me that there's a right angle. Then if it looks equal, it is equal. So measure of segment AB looks like it's going to be 8 because it's the same as BD right there. Arc CD. So if this is 47, then this is 47. So then I can say 180 minus the 47 would be 133 maybe. And arc CDE, CD, that's half the circle, that's 180. All right, little right triangle stuff, Pythagorean theorem. So I'm given two sides. I'm given one leg and another leg. So I could use those to solve for this whole side. So let's do that to start with. I've got 10 squared plus 24 squared equals c squared. That's this whole side. And I think you end up with 26. So this whole side is 26. That's not what we want. We just want that outside stuff. I know that this is 10, so that means that that is 10. So I'm going to say 26. X equals 26 minus 10. So x equals 16. Right here, I'm going to swing that 2.5 around. If that's 2.5, then that means that's 2.5. So this is 2.5. That means this whole hypotenuse is going to be 6.5. And I'm going to say 2.5 squared plus x squared equals 6.5 squared. And 2.5 squared is 6.25 plus x squared equals 6.5 squared is 42.25. So I'm going to subtract that over. That would be, I believe, 36. So that means x equals 6 right there. The 70 degrees right here, it's an inscribed angle, and it opens up to conveniently all of that stuff. So normally I would just say 70 times 2 to give me all that arc that I just drew. So that's what, 140? So that means that whole arc down here equals 140. So I'm going to say 140 equals 70 plus 6x plus 16. So 140 equals 86 plus 6x. 6x equals 54 and x equals 9. Same kind of deal as the last review. These two angles are inscribed. They both open up to the same arc. Therefore, they are equal. 5x minus 2 equals 4x plus 9. Bring the 4x over, you get x. Add the 2, you get 11. Fancy inscribed angles. Still going to multiply by 2 because they're inscribed. Right here, multiply by 2. That's 112. Let's do number 39 next. I'm going to divide by 2 right there. That's 50. And 38, I'm going to say 360 minus the 228. That'll give me this arc right here. And that's 132, I think. So if that's 132, I'm going to divide by 2 and get 61 degrees. Last one. CD. So up here, the 140 arc opens up to 14 as the chord. So we got 140 down here. That means that CD needs to be 14 as well. Okay. Next, we've got arc DCB. I don't like this. I think it should be DBC. Find that. That'll be right here. And you can either do 114 times 2. It's a fancy inscribed angle. That would be 228. Or you could say, oh man, this is a terrible problem. I was going to say you could say 360 minus that 140 right there, but that doesn't make any sense either. So maybe one of those is right. On your test, it will work out nicely, I promise.